Good morning, everyone. Today I will discuss about basics of compiler. So in the last class, some basic points I covered. What is compiler, and some of the people are absent. That's why today I will start again basics of compiler. So what is compiler? So here I want to discuss about what is compiler. First, these are the content I will discuss in this class. Introduction, history, why study compiler, what is translator, structure of compiler, and the compiler using some tools. There are using two tools, Lex tool and YACC tool is there. So we will discuss in the coming classes. So first we will discuss about introduction of compiler design. So what is compiler? Compiler is a translator. First of all, compiler is a translator. To translate high-level language is converted into assembly language or mission understandable language. So that's what a compiler is, a computer program that transforms the source code. It is nothing but high level language code is written in a high level language and into low level language converted. It is nothing but target language. The high level language is nothing but source language, and the low level language is nothing but target language or assembly level language or mission understandable language. This is called as compiler. So once again, compiler is a translator. To translate high level language is converted into mission understandable language. It's important. And let's look at one important example. You can see that regularly we are writing the high level language programs like C, C++, Java. So whatever the high level language is writing in the English. So that language, how should be translated to the computer? The computer is understanding only ones and zeros. But how the translation is possible? See that here, suppose C program is there. C++ program is there. So for x is equal to 3x less than 5 and x plus plus is there. So this language, this is all the language is called as high level language. This is all the language is called as high level language. This language is a high level language. So this is the high level language. And this high level language how should be converted into mission understandable language. The mission understandable language is nothing but the target language. It is the source language, it is high level language, and it is the target language, it is a mission understandable language. So how should be converted? We can see that compiler contains the number of phases are there. Each phase it will be translated step by step overall. After we are getting the output of final high level language output. So we can see that compiler. Basically, there are two things of compiler. In the compiler contains two parts are there. First part is analysis part. Second part is synthesis part. In the analysis part, where the source language is nothing but a high level language. Code is there any errors are there? First, we have to detect the errors, and that errors we should remove. So it is called as first three phases. It contains the 6 phases of compiler. In the 6 phases of compiler, the first three phases are translating the high level language is converted to without errors. That language is there. Okay. After that, the synthesis language, synthesis part, translating the source code into object code. So without errors, whatever the input is given to the synthesis, that synthesis is translated into object code depending upon the type of mission. Every computer is a different mission is used. Some computers are using some type of missions. Some computers are using another type of missions. So that's what depends on the mission. So the translating is done. So that's what every language first we should without errors we are taking the language. That language is converted into object file. It is called as a dot object file. We know that already Java language dot object file is created. So that what, so whatever the translation data without errors, the data is converted into object code. So this is the two parts important in the compiler, analysis part and the synthesis part. In the analysis part, three layers are there. Synthesis part, three layers are there. So in the analysis part, three layers are lexical analysis, syntax analysis, semantic analysis. So these three are the analysis part, and the synthesis part, code generation, code optimization, and intermediate code generation is there. In the synthesis part, first intermediate code generation, after that code generation, after that code this one is there. Okay. So programmer errors are difficult to track the compiler wrongly designed. Generally, every programmer they will invented one language, that is the programming language. That programming language is very difficult because how the high level language is translated to understand the computer, it is very important. Every programmer they invented one language, he must also invented compiler. It is very important because of every language having the separate compiler. For example, C language having separate compiler, Java language having separate compiler, Python language having some separate compiler. So every programming language, they will construct one important compiler language, compiler. Okay. So this is the second part. And now the introduction, one pass compiler. So it is also known as a narrow compiler. It compiles that pass through the source code of each compilation unit only once. So in the number of lines of code is there. So each line will be compiled and at least one time. So that's what it is, the very faster than multi-pass compiler. So one pass compiler is the faster than multi-pass compiler. Their efficiency is limited because they don't produce the intermediate code which can be refined easily. The efficiency is limited because of not taking the entire lines of code. So it will take line by line. So that's what it produce the intermediate code which can be refined easily. That's why it is also known as narrow compiler. And in the coming to multi-pass compiler, there are two compilers I told you, one pass compiler and second one is multi-pass compiler. It is the process that source code or abstract syntax tree of a program several times. It may create one or more intermediate codes. In the previously, it cannot create any intermediate code, but it will create the one or more intermediate codes very easy to refine. Each pass takes the output of previous phase. There are number of phases are there. Every data is comes under phase by phase. So that's what each pass takes the output of previous phase as input, hence required less memory. And it is also known as a wide compiler. The multi-pass compiler is a wide compiler. The one pass compiler is a narrow compiler. So these are the two differences of compilers. So coming to history, softwares earlier computers are written in the assembly language. Generally, in the starting of the computer languages, every software programmer is designing language. It is designed for assembly language because of the assembly language only understand the computer. So that's what every programmer develop the programs in the assembly language only because of the assembly language easily understand to the computer. So that's what every programmer is developing assembly language code. The need of reusability of code gives birth to programming language. So every time we are reusing the code, that's what reusability is there. So in Java also reusability code is there. This need to grow hug to overcome the cost restriction of the compiler. Every time the compiler is compiling the again and again. So that's what the reusability code is there. We can use more times to compile. So there is need not to compile again and again. Just one time it will be compiled. Every reusable code should be compiled automatically. So that's what. So the concept of mission independent programming gave birth to the need of compilers in the 1950. The first compiler was written by the Gary Hopper in the 1952 A20 programming language. The first compiler was by Grace Cooper in the 1952 for A20 programming language. And the first completed compiler was developed by Fortran. We know that already Fortran language, and this is developed by IBM in the 1957. COBOL also there. This is the first language to compile in the multiple platforms. Previous languages are all using in the single platform, but whereas COBOL is using for multiple platforms. There are n number of platforms are there. Any platform it will be working. So that's what the first multiple platform compiler is COBOL. So earlier compiler was written in the assembly language, I told you, and after that high level language is converted. The first compiler of HLL, high level language, was created for Lisp by that author USA in the 1962, which was the self-hosting compiler. Most compilers are more made in C or Pascal language. Any compiler, the compiler design, how they are designed using in the C language or Pascal language. So these two languages are using to develop the compiler design. However, the trend is changing. Self-hosting compiler, which can be compile the source code in the same language in which they are created. Why study compiler? So without the compiler, how the program is translated to understand the computer, how we are getting the output. So it is a big question. That's what compiler is need, because of every programming language we are developing. So we must use the compiler. Without compiler, your program will not be translated to the system. So will not be understand to the computer. So that's what compiler is there. Okay. So increase the understanding of the language semantic, helps to handle the language performance issue, opportunity, non-trivial programming project is there. So high level language is very important to use that every person, but high level language, how to translate in the computer means using in the compiler only. So one more compiler is also there, interpreter. So what is the difference between compiler and interpreter is the compiler is entire program must be compiled at a time, whereas interpreter is it is a line by line compiling. So one line is compiling after the second line is compiling after the third line. It is by line compilation, not entire program should be compiled. So it is a very important difference between the compiler and interpreter. And interpreter it takes more time to build, and the compiler it not take less more time. It is less time to compile your program. So that is the main difference between the compiler and interpreter. So even assembler also there. Assembler is converting assembly language code is converted into mission level language is very easy. So assembler is also like one type of translator, because of assembly level language means move R1 R2 like register RTL language, register transfer language is there, no? So that language is the assembler language. The assembler is converted into assembly level language is converted into mission understandable language by using in the linker and the loader help. So these are the types of compilers, cross compiler, and some other language compilers are there. Java also having one compiler is there. So these are the decompiler. So compiler. So linker, loader. So I told you already. So structure of compiler. So here the compiler having the 6 layers. First one is scanner. It is nothing but the lexical analysis phase. The second one is the syntax analysis. It is nothing but the parser. Third one is the semantic analyzer. Fourth one is the intermediate code generator. Fifth one is code optimizer. And finally, sixth one is the code generator. So these are the 6 phases. Phase by phase, the data will be translated to, and we are getting the target code. So if any errors are there, the error handler is storing the error data, and any special symbols are there that stores in the table manager, symbol manager. It is like, so first one is scanner, parser, semantic analyzer, intermediate code generator, code optimizer, and code generator. So these are the 6 phases of compiler is there. So it is very, very important structure of each and every compiler. Whenever you are creating the own compiler, these are the 6 phases must be there. So the names are different, but these operations are done. So scanner can scan the input program and identify the tokens, and parser can take the tokens to identify syntax. And after that, semantic also we are checking using in the semantic analyzer. After that, without errors code will be produced to the intermediate code generator. The intermediate code generator is sending to the code optimizer. If any unused code is there, that code will be reduced using in the code optimizer. After that, we are getting the code generator. The code generator is creating the target code. So this is the process of compiler, and this is the structure of compiler. There are 6 phases of compiler is there. Okay, let's see one by one in detail in the coming classes. Thank you.